Hello friends, so here we want to basically learn about the NEC24X software, which basically simulate the antenna designing. So by using this software we can simulate the different patterns, output, and different kind of things of an antenna. So here our task is to build a dipole antenna, which will radiate 750 megahertz. So for this you need to first go to the NEC2 4x software, open that software. Okay, now what you need to do is first make your input file. Okay, so you need to make an input file. Before that you need to calculate the geometry, what should be length of your dipole antenna. So first open your terminal and calculate how much should be your length of antenna would be. So calc 3 into 10⁸ speed of light divided by 750 megahertz. So 0.4 meter is your wavelength. So basically half your length of the dipole antenna should be lambda by 2, because you need constructive interference so that you can radiate maximum power. Okay, so so length of your dipole antenna should be 0.2 meter. Okay, good. So let's go to the exit, and then just a minute. Okay, so now you need to make the you need to make your input file. That is basically your program file where you will write all your parameter, etc., whatever you give in your NEC2 software. So first open your notepad. Okay, so this is your notepad, and then you need to start with some commands like cm. So now give your program name, test, write dipole. Okay, now CE and then CN, EN. Okay, so now save it. So I am saving it at desktop. Give the name of your file as dipole1.nec. the extension should be nec, and since I am running Linux, so you need to make it as a Windows format. So this is dipole1.nec at desktop. Okay, now your input file has been created. Now go to the go to NEC software, and then open that file, press Ctrl O, and then go to the desktop, and then open dipole1.nec. now here is your input file. Now press F6. Okay, so now you need to give the geometry of your antenna. So here put wire, and then give a tag number. Tag is basically for identifying the wire, and give some segments. So as instructed by teacher, 35 should be enough. You can give many number, but give basically odd number of segments, so that you can find out the midpoint of this segment. So midpoint of this segment is the 18th, since half of that the 17 plus 1 is 18. 18 is the midpoint of this antenna. Now give the dimensions. So here basically these are the coordinate in 3 dimension. So I want to make the z-axis as your as our antenna. So put 0 0 in the x5, and this is basically the starting point, and end z1 and z2 is the starting and end point of your antenna. So since we know that our antenna length should be 0.2 meters, so give a starting point as a 0.1 coordinate, and 0 0, and then 0.1 as your endpoint. So this is basically the length of 0.2 meter. Now give some radius. So radius should be basically small 0.006 is quite good enough, so take it. So this is basically 6 millimeter your thickness wire diameter, sorry, radius, wire radius. Okay, so now this is basically your geometry, and this is done. And now you go to the source, and now which kind of source you want to apply here you need to give. So we are applying the voltage source on tag number 1, means wire 1, and the segment at midpoint, I mean 18. And here you don't need to give anything to here, and give magnitude as 1. You don't need to give any phase, so just put 0 or something else. Good. So basically your source part is done. Now put here now tick mark yes, so loads. So this will tell you about the property, show you the option to fill up what kind of property you want in your wire. So so basically this is your wire is conductor, and you're referring to the wire 1, so put tag number 1 and then put 0 0. So it will make entire wire as per your wish. So and then choose the conductor. So your conductor is copper, so your entire wire will be made of copper. So now this is done, and then go to the frequency and put here 750, because you want to have 750 megahertz as radiation. Okay, now make a ground plane as a free space, because right now we want to see the free space as a ground. Okay, now this is done. So recheck once again. So wire, tag, segments, and your geometry and your radius, and source, voltage source, tag 1, segment, and then magnitude and phases, etc. Then your load type, wire conductor, tag number, segments, and made of what? Copper. Okay, now save it and then calculate. So since you are interested in far field pattern, so click on the far field pattern and generate it. So this is basically your polar plot of your intensity pattern in decibels. So this is like a donut shape. Now you can see the 3D pattern of this intensity pattern also. So this is your antenna, as you can see. This is the z-axis. Now you can see the pattern also. So this is like a donut shaped. Okay, now you can see the transparent also. So the radiation pattern along the z-axis is a donut shaped, which we expect, and that's all. I mean, okay, now you can change your color, etc. You can modify, you can play with this. So since I like green color, so let's make it some greenish. Okay, done. So that's all. You can play with the dimension, etc., and you can see the radiation pattern. So that's all. Thank you.